Okay folks, so we've got our last video on this simplifying complex expressions or complex fractions. And this is really what we're going for in this pre-calculus class. So we've got a strategy down, this is one of the ones I asked you to try, for simplifying complex fractions where the strategy is to multiply by the LCD of the minor fractions over themselves. And I mentioned at the beginning of this pre-work that maybe you know a different method for simplifying complex fractions, and that method has gotten you pretty far so far, which is wonderful. But I want to point out that it is not as efficient as the method that I'm showing you here. Specifically, this method that I'm showing you here is more applicable to a wider variety of situations. And to help kind of get you ready for that, I want to show you that we can use this method very easily on our trig expressions. One thing that you might see here is this may not look like a complex fraction. It just looks like a single fraction. We see a single fraction bar. So what we want to jump into then to visualize this as a complex fraction is to remind ourselves of some of our reciprocal and quotient identities for trigonometry. And so by my quotient identity, I can rewrite this cotangent of x as the cosine of x over the sine of x, all divided by, now because I'm making this a complex fraction, I make this bar thicker and wider, easier to see, and then this would be 1 over the sine of x minus the sine of x. And here I would argue that it would start to become a little bit difficult to try, students like to remember a phrase called copy dot flip or something like that. And while that is a valid method that works in some situations, I don't think it's the best method for simplifying this expression here. Instead, we've been trying to learn this new idea of multiplying by the LCD of all of the minor fractions. And here the LCD of all of the minor fractions is a sine of x, because I have two minor fractions in this expression, and both of them have a denominator sine of x. So that we've now identified that LCD of the minor fractions, so let's multiply by that LCD over itself, that convenient 1 here. And you see that this strategy works almost regardless of what these expressions, these complex fractions, are composed of. And so now I'll go ahead and distribute the LCD into the original fraction. So when I multiply the numerator of the major fraction by this factor of sine of x, when I distribute that, I'll just be left with a cosine of x, all divided by, and then in the denominator, when I distribute this sine of x to both terms in the denominator, we end up with 1 minus, and then sine of x times sine of x will be sine squared of x. Well, that's great. We've achieved, kind of partially achieved our goal, or at least we've rewritten this expression, but our goal here actually is stated to write this as a single trig expression, and I still see two trig expressions. What do you think we're going to do now? Looking at this messy expression here, what could we do to clean this up? Well, one thing we could do is we could pull in our Pythagorean identities, and one of our Pythagorean identities says that the cosine squared of x plus the sine squared of x is equal to 1. That's usually how we have it memorized, but remember that I can rewrite this lots of different ways. For example, if I were to solve for cosine squared of x, I get that that's equal to 1 minus, and I'll make sure you can see that, 1 minus the sine squared of x. So what that means is I can take this expression right here, 1 minus sine squared of x, and replace it just through substitution with the cosine squared of x. So if I do that, we end up with cosine of x, leaving the numerator alone, and in the denominator, I'm going to replace this with cosine squared of x. So that was using this substitution that says that the cosine squared of x is the same as 1 minus sine squared of x from our Pythagorean identity. So I can now rewrite this as just 1 over the cosine of x, which maybe is an okay place to leave it, but by our reciprocal identities, I can rewrite this as secant of x, and that's probably the best way to rewrite this complex trig expression as just a single trig expression. Okay? This is going to take some practice, and this is a skill that you will need to develop for both Calculus 1 and Calculus 2. is this being comfortable with manipulating these trig expressions. So I want you to pause the video and give this a shot. You have a solution, but please try to do it on your own, similar to the work that I did here. It's a very similar question. Try to work it on your own, and then you can check the hyperlink solution as necessary. So pause the video and give that a shot. Okay, so now that you've tried that, the last thing I want you to do is I want you to rework a very similar problem to this. And so I've embedded a MyOpenMath problem that you can click on. When you click that hyperlink, it'll pull up. You don't need to sign in or anything. It'll just pull up an embedded MyOpenMath problem. And this looks very similar to one of the ones that I've had you try, and you can give it a shot. You can submit the answer, and afterwards you can check it. Let's see here, if we try something here, like maybe we just think it's going to simplify to the sine of x. Hopefully we're not right. Oh, well, we don't even have the right variables here. Maybe we think it's going to simplify to the sine of t. Please, folks, don't let the fact that I am just plugging in a random answer in any way imply what you should do with this problem. Instead, it is very important that you work through this problem. This is the goal. The goal is not to get an answer. You're getting no points for getting the answer. The whole goal is to learn how to work through these complex expressions. And you can click on this, see the answer when you're done to see if you got it right. There are 2 video help problems associated with this. And then if you didn't get the right answer, you can hit try a similar question. And now we get a different version of a very similar question that you can try. Please work this until you get it correct a couple of times, and then take one of the versions that you were asked that you got correct, copy down the question. So I want you to copy down both the question and your entire solution, not just the answer. I don't really care what the answer is to this question. I care that you can show the work to get there. So copy that down, and that's something that I'll grade you on for this pre-work. Okay, folks, that wraps up this somewhat lengthy pre-work. Hopefully you feel a little bit more confident in working with rational expressions now. If you find this difficult, that's okay. First of all, this is a tough problem. These are tough problems. If you find this difficult, keep practicing with it, but also feel free to come by and see me during office hours, and we can work on them together. Thanks, folks, and I will see you next time. Bye-bye.